warranted hearing again and again about the need to maximize nuclear reactors. And of course, the need for this international collaboration to make this happen. And of course, the need to train and mentor the new workforce. But there is a new question here, which is how do we create the ideal conditions for a successful delivery of those projects? And I'm not only talking about the industrial and operational point of view, I'm also talking about the economic and political perspective. So here to discuss and elaborate a bit more about this, I have our next moderator, Paul Haworth, the CEO of the National Nuclear Laboratory. Welcome. I'll hand in the microphone to you.
Well, good afternoon, ladies and gentlemen, and delighted to have been asked to chair this panel session. I have to say, having arrived here this morning and seen 20,000 people here involved in the future of nuclear and the amount of energy and enthusiasm that is present, it really is inspiring. I think it's a fantastic time for young people, as Samo was saying, to inspire them and to be involved in the nuclear industry. I wish I was probably 20 years younger myself, but a great opportunity for how we can take new nuclear build programs forward. This really is an opportunity for a renaissance of nuclear. However, as mentioned, there's a key factor that we need to address, and that is around serial production and fleet build of nuclear reactor systems. To really get this renaissance up and running, we need to ensure that we can deliver new nuclear build projects to time, that we can learn how we do it, that we can get the supply chain up and running, and we can demonstrate to the financial community that we can do this at low risk and we can guarantee the returns and the deliveries. That's why this panel session is going to be focused on new nuclear projects getting ready for serial production. The opportunities here are immense. The learning that can take place and getting ready for fleet delivery of nuclear. However, there are also some key challenges that need to be addressed with regards to getting the skills ready, making sure the supply chain can deliver, and addressing the point over standardization versus diversified fleet. And how do we balance innovation versus a standard product? So to help me this afternoon to unpack some of these issues, I'm going to introduce my panel members and ask them to join me on stage. I'll introduce them one by one. So first of all, if we'd welcome to the stage Mr. Alan Transer, who is the General Deputy Head of Industrial Quality and Nuclear Skills at EDF. Thank you. We have Deanne Cameron, who is Head of Nuclear Technology Development at the NEA. We have Mr. Ken Hartwick, who is the President and CEO of Ontario Power Generation. Mr. Jiang Tai, who is President of China Nuclear Power Engineering Europe. And a late addition, but I'm delighted he's been able to join us, is Mr. Mohammed El Brakai, who is the Strategy Director of ENEC. Okay, so many thanks for joining me on this panel session. The first thing that I'd like to do is ask each of the panel members to say a few words to set the context of their interests and involvement with regards to serial build and fleet production. First of all, though, I'd like Diane Cameron from the OECD and NEA's perspective to provide a bit of an overview with regards to where we see things up to at present. So Diane, over to you.
Good afternoon, everyone. And Paul, thank you so much for the introduction. It's a pleasure to be here on this panel with such esteemed colleagues. And I appreciate the invitation to provide some sort of opening remarks, at the NEA, as an international organization, we spend a lot of time monitoring and thinking about global trends. Clearly, as Director General Sama Bilbao-Lyon mentioned, this is an important moment in time. This conversation we're having today about cereal production exists against the backdrop of a climate change emergency, an energy security priority, and it's in the lead up to COP28. We're very proud at the NEA to have contributed to the momentum for COP28. In particular, I want to sort of anchor some of the discussion around this target of tripling global installed nuclear capacity by 2050. In 2022, NEA released the first analytical piece of work on this question of what should the role of nuclear be in net zero by 2050. And our analysis indicated that, in fact, global installed nuclear capacity should triple by 2050 to keep the 1.5 degree scenario alive and to reach net zero. We are delighted that countries at COP, governments are expected to endorse and commit to a tripling of global installed nuclear capacity next week at COP28. That is an ambitious, if not audacious, objective, and it is an incredible opportunity. You can feel the excitement here at WNE. I've been coming to WNE for several cycles now, and you feel the excitement. You feel the sense of opportunity and the sense of purpose. There are, of course, also a number of challenges and a number of ways that that we could be delayed, that we could be sidetracked, and we need to be conscientious about those and address them. So reflecting on global trends, we convened at the NEA one of the first ministerial meetings to be held amongst nuclear energy ministers at the end of September in Paris. We called it Roadmaps to New Nuclear. It was 20 ministers and 40 CEOs from countries that have committed to the use of nuclear energy in their pathways to net zero and in their energy security strategies, and in fact have committed to build significant quantities of new nuclear. So representing a big part of that step towards tripling by 2050. We see an enormous level of ambition and targets being set. We see policy changes happening. I'll just name a few. A reversal of nuclear policy in Korea in recent years. France and their announcement to build 14 new large-scale reactors. Japan's commitments to restart and then replace, and starting a conversation about new build for the first time in many years. The UK setting a target of 24 gigawatts of new capacity. In Canada, enormous momentum on SMRs across multiple provinces for different kinds of applications, so different kinds of SMRs, but also recently a new conversation about large-scale nuclear also, including an announcement to build 4.8 gigawatts at Bruce Power. And in the US, the Inflation Reduction Act and many other measures aimed at preserving and encouraging the refurbishment and life extension of the existing fleets, but also accelerating and investing in innovation and new deployment. You know, across Europe, I won't go into great detail, but just to give you a sense of the momentum in this tidal wave. In Europe, we see Poland and Bulgaria, Czechia, Slovakia, Romania, Finland, Sweden, Estonia, Hungary, amongst the countries that are moving to deploy new nuclear. Even in Belgium and Italy, where we previously anticipated a phase out of nuclear, we see the conversation opening up and a bit of a reconsideration on whether that's the right strategy. So bringing this to the concept of serial construction, we have to address the elephant in the nuclear room, which is either a reality or a perception of nuclear delays, nuclear new build construction delays and cost overruns. we have to understand that, we have to put that in perspective. It's a common critique, or there's a lot of, well, there's a common critique. But putting it in perspective, we need to consider that other large infrastructure projects face similar challenges. It's not necessarily unique to nuclear. Rail lines, gas pipelines, airports face similar challenges. So there's something about large infrastructure projects that is challenging. And when we look at nuclear in particular, nuclear large-scale new builds, our analysis at NEA in a report we released in 2020 essentially concludes that almost all of the causes of delays and overruns of the examples that are often cited can be attributed to basically atrophy. Atrophy of the talent pipeline, atrophy of the supply chain that was the direct result of underinvestment over the course of 20 years. And so when we came back to nuclear new build, skills had been lost, supply chain had been lost, even regulatory capacities had been lost. But we need to have a more fulsome view of the potential for nuclear to deliver on time, on budget. If we look at examples around the world and in the last the last several decades of history, we see many examples of success, of serial production delivering delivering those learning curves, reducing costs per unit. Russia and China have these programmatic approaches that are delivering very efficiently. The UAE delivered 4 reactors in 10 years. And we look back at the experience in some of our other countries in the room today. 59 reactors were built in 20 years in France in the 80s and 90s. In Ontario, Canada, 18 reactors were built in 10 years in the 70s and 80s. In Korea, 18 reactors were built in 20 years in the 80s and 90s. So what we really need to be asking ourselves is, what were we doing right then, and how do we do it again?
Excellent. Thanks very much, Diane. That's a really good overview of where fleet build is at present. I'm just going to ask each of the panelists now to provide their perspective a few minutes, and then we'll move into some Q&A. So, Ken, would you like to go next, please?
Sure, and thanks. Thanks, everybody, for being here. Yeah, I'd say firstly, Ontario Power Generation, for those that don't know us, we operate about 18,000 megawatts of electricity generating assets in Canada and the US. It's virtually every technology. I think the only technology we don't operate is wind farms. And we've just have teams now in Poland and Romania on nuclear-related projects. So we're sort of expanding out of the Canadian context. And just to pick up on Deanne's comments for Canada, I think it's right. So we have 19 operating reactors in Canada across Bruce Power, ourselves, and New Brunswick Power. And Canada has now started a process to very actively begin to expand out the nuclear footprint across not just the two provinces that it's currently operating in, but several others that have now begun to express a level of interest in using nuclear to decarbonize the way that we've talked about in this room and previous people have talked about. So I think the path is really clear, and I think to a large degree, to pick up on the 2 points that you just made, which I think are right, is we have a life extension project at Darlington, so it's a 3,600 megawatt unit, 4 units, or station 4 units. We're 3/4 the way through. The last unit was brought on 169 days ahead of schedule and under budget. So I think when we get to the nuclear costs too much, takes too long, I agree. Those are choices. They're not decisions. So these can be done really well, and I attribute a lot of the success to our partners at Bruce Power, who have adopted exactly what Sama talked about, which is cooperation between nuclear companies to do things right. So I think we have to dispel the myth that this can't be done well. It can be if we choose to do it in the way. I'd say secondly on the sort of the serial part, which is part of the conversation today, it's we've also announced we're going to build 4 SMRs on one of our sites of a GEH technology. And again, our view on whatever the technology bent is, not necessarily the one we've selected, is that we have to get it to the point where you finish the design, you do the design, and that is the design. The thing that let's make it better and different every single time, that is perhaps one of the choices we make so we cannot be successful in building new nuclear. And I think what we intend to do on our site, we will have the first reactor operational in 29. We're going through the licensing process now, but really our intention is to make sure all 4 are the same, and I hope the other provinces in Canada or others that choose to pick the same technology all adopt the same mantra. Let's make them the same, make them easier to do. It's hard enough to begin with, and ensure that we can have success doing that. Thank you.
Thanks very much, Ken. Really interesting. It's great to hear actually some really good stories that are out there in terms of how new nuclear build projects are learning from the experience of refurbishments, etc. I want to return back to that point a bit later. But I'd like to hand over to Mr. Tai now to give a bit of a view from how things are going in China, which again is also progressing new nuclear build at pace.
Okay, thank you, Bob. Thank you all. Good afternoon. I'm glad to be here to talk to you. Thank you very much. I'm from the CNPE, China Nuclear Power Engineering Corporation, which is the largest nuclear power plant delivery company, I think. It's also the largest in the world. With the capability of the research and engineering and equipment integration, construction, as well as commissioning. In the last 16 years, CNPE delivered 14 units nuclear power plant. And right now, there are 11 units are under construction. In the future, there are 17 units planned to be built. And regarding the under construction unit, there are from north to south. In the east and north, in Liaoning province, Xidapu nuclear power station, there are 4 units are under construction. 2 of them is WNE 1000 cooperated with Russia. And 2 of them is Cap 1000, which is the localization unit of the AP 1000. In the East China Jiangsu province, there is Tianwan nuclear power plant, and 2 units are under construction. It's also the WNE 1000 unit. In the east south of China, Fujian province, there is Zhangzhou nuclear power plant. Right now, there are 2 units, HPR 1000 units are under construction. In the south of China, Hainan province, there is a Hainan nuclear power plant. In this power plant, 2 units of HPR 1000 are under construction. And as well, 1 small modular reactor demonstration unit is under construction. That's all. Thank you.
Thank you very much, Mr. Tai. So that's pretty impressive. So not only is it fleet build, but it's fleet build of different types of reactors all at the same time. VVRs, HPR 1000s, AP 1000s, EPRs, everything ongoing. That's pretty impressive. Let's come back to some of the learning from that a bit later. Mohammed, the build program at ENEC and Baraka is probably one of the best known success stories to date. So I'd like to just hear a little from yourself on the success of that program.
Thank you. First of all, thank you for having me and inviting me to speak. As you know, a little over a decade ago, we started our program at the Emirates Nuclear Energy Corporation. And the idea was to diversify our energy mix. We start right now, we're happy to say we have 3 operating plants safely, and the 4th one is coming very soon. 2 weeks ago, we received the operating license. So we're going to start all the fuel load preparations and loading the fuel. Once we have the 4 plants up and running, that would cover 25% of the country's demand. At the same time, those 4 plants will help avoid 22.4 million tons of CO2. Now, 22.4 million tons of CO2, this is equivalent to 4.2 million cars off the road. So it's a major decarbonization effort. And it's really nice to be here talking about this success just right before COP, because we think nuclear is at that pathway. And we're happy, we're enjoying very clean electricity right now, and happy to support and be a part of this journey. Thank you.
Thank you, Mohammed. It does deserve a round of applause for the success that they've had in Baraka. And then finally to Alan to give an overview as far as EDF's experience is concerned.
Yeah, good afternoon, all of you. We are here at WNE, so we are well aware of climate change and the fact that nuclear industry is a key enabler, part of the solution as explained by the other speakers. Moreover, I would add that EDF raison d'être is to build a net zero energy future with solutions, with services that are lower carbon, of course, more efficient, less of an impact for the environment and for people. We are here in France, one of a country that has built a large nuclear fleet, up to 58 reactors. That gives also a long-term visibility on an ambitious program for our industry, with 3 pillars. The first one is the climate adaptation and life extension of our operating nuclear power plants. With the Grand Carénage program, EDF is definitely committed to a massive program to upgrade its current fleet in order to extend the life of the fleet, of course, while always putting safety first. But we want to extend the life of our fleet beyond the 60 years. Second pillar is EPR2 model. We have now a program of 6 new EPR2 nuclear plants, plus 8 others in option, means 14. The first 4, 2 at Penly, Normandy, 2 at Gravelines in the north, and then after 1 reactor per year in the decade between 2040 and 2050. 1 reactor per year, it also represents between 3 to 4 billion per year of money in the 20 years to come for our supply chain. That's huge, and that's a testimony of EDF's commitment to engage into a new massive program in construction in its home country. Last but not the least, I have to mention the UK, because we have 2 reactors in the UK at Hinkley Point C in the Somerset under construction, plus 2 others to come to be decided. We hope the final investment decision next year at Sizewell C, with full replication of design between those 4. And we hope more to come, because we are here in Europe with a lot of countries which are looking further to new nuclear facilities. On EDF, we are promoting a strategy of fleet effect all across Europe, because we believe that replicating the same technology is a key success factor to create cross synergy between projects, to have positive benefits to leverage positive benefits for the European supply chain.
That's very good. Thank you very much, Alan. Okay, so we've got plenty of experience across the panelists of new nuclear build projects and fleet build. Alan, I'd like to come back to you first with regards to the historical experience that you've had in France. And this goes back to the 1980s and the construction of the N4 fleet. It's something that we've been interested in the United Kingdom to understand how you've done it. Could you explain a little further about how that program did proceed, how quickly the reactors were brought on the bars, and the lessons that were learned?
Okay, yes, we have a huge, brilliant history. In only 20 years, it was at the end of the previous century, France has built 58 nuclear plants. The scale and the speed of this construction, up to 5 reactors per year, also means that France still holds the record for speed in reducing its CO2 emission. And we have up to now more than 2,000 reactor years of experience. The main factor behind this success is the momentum generated in the industry by a long-term vision and a coherent programmatic approach. This strong political signal is key. It has enabled industry to structure itself into a consistent end-to-end supply chain. With EDF, the prime contractor and operator, who also integrates design, construction, and commissioning, with some key tier 1 suppliers responsible for major equipment and civil works, and with a rich network of small and medium-sized industrials. This dynamic has driven everything: the recruitment, the training of the people, the investments in industrial facilities, plus a set of codes and standards for all industrial players. During this period, reactor design has followed a gradual evolution with, on the one hand, the continuous improvement based on feedback from the construction and operation of the previous one, on the other hand, the willingness of standardization through successive technical stages. This approach has led to 3 successive power levels: the 900 megawatt, then the 1300 megawatt, then the 1450 megawatt. The results of this dynamic is an homogeneous nuclear fleet. The standardization, of course, is still a huge benefit for us because it still generates fixed cost synergies, for example, in supplier qualification efforts, for example, for spare parts. It also leads to a learning effect during the construction with some productivity gains, but also during the operation with some productivity gains, because you can also only, I would say, improve performance through repetition. Beyond that, I would say that this programmatic approach is a fundamental success factor in optimizing all the benefits of replication, because it provides the visibility to mobilize all the actors being sure that each project to be properly executed will lead to another project, and then we will have to drive performance improvement within the program, project after project. And that's the key for success.
So 5 reactors a year, you see, it is possible to do this. We will get there. The learning that was captured from the 1980s, Alan, now with the new build program in France and that long-term vision that you noted, which is so important, are you still able to capture that long-term, the learning that you've achieved and apply it to the deployment of EPR2? Can you still capture that learning now?
The answer is yes, and as you know, perhaps, I'm leading the Excel plan since 3 years, which is our plan for EDF and its supply chain, in order to gather all the lessons learned from the past, but also all the lessons learned from the difficulties we experience at Flamanville in order to regain the cutting-edge level in efficiency, in quality, in rigor required for our industry. And indeed, EPR2 is a part of a process of facilitating the construction and industrial quality of EPR model. And it incorporates performance optimization based on this feedback from Flamanville in terms of design simplifications, of course, in terms of reduction of the number of equipments using standard parts in catalogs, in terms of prefabrication or even modularization of a certain large of assemblies, all those being meant in order to facilitate the on-site work, because time to market for construction, that's the key. Then we cannot have to forget digitalization, which is completely new, but with EPR2, we are the first reactor which is fully digital, means a 3D mock-up up to execution design plus a 4D planning, and all is entirely in a data-centric approach. Means that data becomes the single source of information for EDF on all the suppliers, and it's really also important with replication in order to keep the, I would say, the memory, you know. Of course, also, we have the early involvement of all the supply chains, starting to work with us during the basing design in order to implement the very efficient method statement, the very efficient catalogs within the design in order to ease the industrial feasibility. And last but not the least, we have a documented feedback from all the people from EDF, all the people from Framatome, all the people from the supply chain who have worked on the first EPR generation, some of them at Taishan, some of them at Olkiluoto, some of them at Flamanville, some of them at Hinkley Point C. At the end of the day, what we have to promote is first, the fact that our industry is not apart. There are some basics that you can learn from all other industries regarding mega projects. It could be from oil and gas industry or airplane industry or space industry or naval industry. But there are some standards you could apply, one of these being the governance. We have to install a very strict governance in order to, I would say, be completely sure that you are not getting in the next step without a very strict handover from the previous step in order to limit as much as possible the rework. Second, we need to remain pragmatic and humble in our industry due to the huge difficulty due to the regulation. Of course, we have a very demanding regulation, and due also to the huge number of parts we have to deliver and the huge number of interfaces we have to manage. And the more complex it is, the more simple we should act. That's why we have to streamline everything we can, starting with the technical specification or the way to make the oversight. That's why we have to replicate, to copy everything we can in order to make those projects as simple as we can.
That's really interesting. Some key points raised there. Simplification of the design, limit the on-site works, digitization, prefabrication, governance. I think that's a really key point, not wanting to rush ahead in the project. Mr. Tai, could I turn to yourself now? The learning that you found in CPNE with regards to the new nuclear build projects. What's gone well? What could go better in the future from your perspective?
Okay. Regarding your questions, first I want to say some word regarding the lessons learned. And firstly, safety and quality is always is always the first priority of all the relevant of the construction nuclear power plant. There is a slogan inside my colleagues that is slow is fast. I try to explain the meanings of this slogan. You guys can figure out from the safety and quality view to try to figure out the meaning of this slogan. Around the year of 2008, there is an ambitious plan for construction nuclear power plant in China, and it's working well. It's going well. In the year 2011, Fukushima accident happened. At that time, all nuclear power plants in China, both in operation and construction, are required to perform the safety assessment. Remedial action should be implemented according to the result of assessment. 3 years later, the construction was resumed with a higher standard. At that time, CNNC and CNPE developed the third generation nuclear power plant, that is HPR 1000. So, from my point of view, the good situation right now in China for the construction of the nuclear power plant partly rely on the stop of 12 years ago. So nowadays, protecting safety and quality has become the consensus of all relevant participants of the nuclear power plant construction. I think it is also essential to give the confidence to public and the government and towards and stop fleet built for the nuclear power plant. This is I want to say for the licensed land. Thank you.
Thank you very much, Mr. Tai. It is a key point that we mustn't forget, that the safety aspects associated with new nuclear build. And whilst we spend a lot of time focusing on nuclear safety, we mustn't forget industrial safety on nuclear sites as we're building at the same time. Key point. Thank you. Ken, could I turn to yourself? OPG and the SMR program. Could you elaborate a little further, please?
Sure. Maybe just a couple of things. So yeah, so we are in the process of getting our license to construct to build an SMR on one of our existing nuclear sites. So we should get that license to construct at the very beginning of 25. Our hearing's the end of 24, and then we'll proceed to build 4 on the site. And I think there will be other multiple deployments across the Canadian landscape of the similar technology as we move forward. You know, the one thing, and just picking up a little bit on the theme as to how we're trying to approach the project is, I would want to caution people a little bit. Trying to learn too much from the 80s and the 90s is a little bit like trying to figure out how to use a DVD player. It just may not be that helpful anymore. So I would really encourage people to go to countries and projects that have done really, really well. So both the gentlemen sitting next to me that have very recent experience on builds, I think that's where we can learn the lessons, whether on both on the construction itself, which is a little bit technology independent, but more broadly learn those lessons. And then, you know, I think at both our Darlington site on the refurbishment we're doing, the Bruce Power life extension that is happening, I think those are the lessons that we want to learn and want to bring to new build anywhere. So like I say, I often think on these things, if you want to do something well and repeat it multiple times, which I think the theme of the panel is, look at people who have been successful and why they've been successful, and then try to bring those learnings and people to the table to ultimately build. And I think that's the way we'll approach our project, our SMR project, is again, looking at other successes, but not looking too far back. Lots of things have changed, and I think we undervalue how smart our young people are relative to our experienced people, and I think that's a value and a lesson that probably is the first one I would encourage everyone to learn is go to great projects where it's done well, and place a lot more reliance on our young people. They're much, much smarter than someone my age, or many others that have been involved in the industry, and we need to utilize that as an asset, and count that it will take those lessons learned and actually learn them.
Could you elaborate a little bit further on the successes, certainly that you've had through the refurbishment program, and how you're applying that to the SMR program?
Yeah, so it's I think on our refurbishment, what we've seen going from our first unit that we brought back into service to the second one to the third one, which is will return to service in the late summer of 24. We've seen about a 12 to 15% efficiency as you go from unit to unit. And it's the same thing as we look at our Darlington SMR project. We know the first one's going to be a little bit more expensive. We get it. We have partners that are learning with us, and we want to take the same type of approach so that as we go from unit to unit, there's a big difference between writing a lesson down and learning it. And that's sort of the mantra we've adopted internally, is let's make sure we write it down or borrow it from others that are very successful, and then let's make sure we learn it. And that's why I think the value of our younger people, because they are very anxious to learn. Maybe some of our more experienced people already know. So
what about the supply chain that's supporting you for the refurbishment program? Will you be utilizing that for the SMR program as well?
Yeah, in Canada, I think we're really, really fortunate. We have a really good supply chain across the reactors we have, nuclear qualified, both construction, engineering, and manufacturing. And so a big part of that supply chain will then just roll in and begin to do work for the technology we're going to build on the SMR. And that supply chain has really been kept in place because of the refurbishments. Our case, $12.8 billion. Bruce Power, I think, is a little bit more than that. They have more units they're doing. So we're fortunate that that supply chain is there. So we're not trying to the earlier point, trying to rebuild something because it's sort of gone stale over time. So call that a bit of luck, I think, on our side.
So I guess it's back to Diane's point, to avoid the atrophy, that if you didn't have a future program, you would see the loss of the skill base and the supply chain as well.
Absolutely. Then you'd be back to building, maybe not from square one, but close to it.
So, okay, that's really interesting. So you've got a supply chain in place that you want to use for a new nuclear build program. Could turn to Mohammed now. You've effectively started from scratch and been incredibly successful. So a very different approach. Can you just elaborate a bit further? What's the reasons for it being so successful, Mohammed?
The Emirates Nuclear Energy Program, when it established that program, it's one of the most strategic, biggest programs that we embarked on as a country. So given that strategic importance, it had a lot of leadership support, a lot of government support, which was really evident, that helped us a lot to achieve what we wanted to achieve. Having said that, starting with the right policy that we have, and this is the UAE Civil Nuclear Energy Policy. It's online, and we call it the golden standard. That was the starting point where we commit to highest standards of safety, security, and non-proliferation. And from that policy, we started strategizing our roadmaps for success. So we put a roadmap that's putting all that we need from a nuclear program from A to Z. So that roadmap by itself has more than 300 pages, about 241 recommendations, and I'm happy to say we checked all of those recommendations. Being a strategy guy, and I've seen how the different strategies and different waves throughout the program and different focuses, having the right people at the right time was really evident. the right partners that we have in place. We have to make that deal bankable. The right governance also we need to put in place. All of those factors help the success of the project. One point I'd like to mention that what Diane mentioned as a challenge, which is the schedule and cost. Like I'm happy to say within our project, we're relatively on schedule and cost. And that happened with a lot of commitment and hard work on program management, on schedule adherence, on oversight, strategic oversight also that really contributed in putting us all on the right path. One point I'd like to mention also on the learning rates. When we are in a big mega projects, the learning rate is something not to be underestimated. Something is an industrial term, we call it as a breaker to breaker, which is once you pour in concrete till you load the fuel. So for Unit 1, that took us about 7.9 years. For Unit 3, shorter. For Unit 2 was shorter. Unit 3 even shorter.
How long, Mohammed? How long was it? Roughly?
39% from Unit 1 to Unit 3.
39%?
Yes, 39%, and that comes to the importance of lessons learned and improving those lessons learned, capturing them and implement them in the next round. And this is one of the key strategic things right in the beginning when we decided to build those 4 plants at the same time. So we're taking the lessons learned from unit to unit to unit. And it's been really remarkable.
Yeah, no, it's a fantastic program. So that learning, how are you going to capture that? And are you looking at helping other countries? Because you don't want to lose that learning now.
Yes, great question. So we've been working closely with the IEA as a major partner with us that really we benefited from. So we've been sharing those lessons learned through their forums. Also, we've been sharing it with WNE, the World Association of Nuclear Operators, which the president of is our MD and CEO, Mr. Mohammed Al-Hamadi. And we've been sharing those lessons learned through different forums within WNE. Also, as you may have heard, at the last G7, President Biden mentioned the consortium of US, UAE, Korea, and Japan. We're helping the Romanian project of the SMR program. So a lot of ways how we could support and help different new builds, also with consulting, how to build a new build from as a green field or the brown field to stick with your schedule and cost. So a lot of ways how we could support. We made sure that we captured all those lessons learned and capture all those institutional knowledge, because when you embark on this big mega projects, it's very important to do so.
That's a really, really interesting project, and the learning that's taken place and how it can be applied. So I guess going through like WNE and INPRO and the IAEA, so other countries are able to tap into that knowledge. That's the intention.
True.
Fantastic, excellent, thank you. Diane, the challenges associated with new nuclear build as far as fleets go, what do you see from NEA as the barriers? Is it regulatory? Is it finance? Is it supply chain? Is it loss of knowledge? All the above?
So I think if I had to distill it to sort of just brief conclusions, I would say that people use the phrase paradigm shift. There's a transformation in energy planning and that needs to happen, and we've seen it. We see it in China. We see it in Russia. And we're hearing about it from France, just starting up. This programmatic approach. Now, whether you need a programmatic approach or whether it's a shift to think about fleet deployment instead of project by project, or whether it's a transformation to a product approach for some of the SMRs, some degree of of planning beyond individual project by project planning. Some degree of planning, coordination, and foresight is needed. And we have we've done quite a lot of analysis on the status of SMRs around the world. And, you know, one of the promises of SMRs is the benefits that might result from serial production or mass manufacturing. We don't see any evidence that the paradigm shift has started in earnest in the majority of the world. We don't see the evidence. Most of the SMR projects, proponents and developers are laser focused on their first of a kind. Understandable why that might be. The only places where we see that the next step has started to a fleet deployment approach are examples in China and Russia. So there's really a transformation that has to happen, and in some ways it's about systems level thinking. It's about looking beyond individual projects and seeing how they connect to a bigger ecosystem, a bigger industrial ecosystem. It's also about thinking about individual projects in the context of how they're going to integrate with other forms of electricity and energy for heat and from renewables. And there's maybe one more thing that I'll say on the question of systems level thinking, because I think for me it is about systems level thinking, which is going to lead us to think about fleets, how they integrate, how to plan them over time. There's something also about the economics of nuclear that requires systems level thinking that's worth noting here. When we think about energy deployment on a project by project basis, it leads us to ask questions like, what is the levelized cost of electricity for a technology at a site? And it leads us to ask pretty narrow questions and to rely on analysis of LCOE, which really only paints part of the picture. When you take a step back and look at things at a systematic level, at the level of integration with the grid, but also at the level of cost learning curve and cost reductions through successive deployment, you get a very different picture of the economics of your system. We know why decisions are taken, or at least have been taken in the past on the basis of LCOE. It's an easy calculation. It's readily available, but it's incomplete information, and incomplete information leads to bad decisions. It's harder to take a systems level view, but a systems level view is what is needed in order to enable good decisions and in order to enable the planning of serial, what's the topic of this thing? Serial deployment?
Serial deployment.
Serial deployment.
Systems level thinking is definitely going to be required for serial build. You mentioned around this laser focus on first of a kind build. So in my country, in the United Kingdom, we're building EPR. Alan, what's the transition in terms of the learning that's going from the EPR build programs into EPR2? How are you capturing that?
EPR2, in fact, is part of a process of facilitating construction on industrial quality of EPR model. So we want to incorporate everything we can from the past experience. And as you said, we don't have to promise someone the earth, but with the learning curve, we can target 30% savings, both in time to market and in cost, of course, through the different levers I already mentioned. And yes, as I often say to my engineers, we don't have to be too clever, we don't have to be too smart, we just have to copy. That's and to think that our customer is the one who will make the assembly, is the one who will make the manufacturing.
We've got to resist wishing to always change and improve things, haven't we?
Yes.
The difficulty is, as nuclear engineers, we always want to innovate and look to improve. We've just got to be strict and standardize things. As you mentioned earlier, I think the governance is very important to have in place. You've got to be strict.
Because sometimes the best is the enemy of the safe, you know, also.
Thank you. Mr. Tai, the learning in China, CPNE, how are you capturing that learning? Do you capture it centrally and then apply it to the next build project? How do you manage all of these different projects and the learning?
And this is managed by centrally by CMPE by some kind of means. For example, the information management systems and experience feedback systems, as well as the top 10 management systems. These systems developed by CMPE and worked well. And from this, these systems, all the informations can be shared entire company. Yeah.
And that's proved successful. You've seen that knowledge getting passed on to future build projects.
What's your question?
So are you actively seeing that knowledge and learning being passed on to the next build project?
Yes, yes. Regarding this issue, I think is to balance how to balance the design change and the standard approach is a big problem for us. Generally, the innovation of the design change is encouraged in CMPE. But from schedule and cost point of view, the standard approach is appreciated. For this issue, there are many proposals from design institute, from construction, from the manufacturing, from the commissioning, as well as the operation. These proposals are carefully studied by the design institute, and some of them are adopted in coming nuclear power plant. And which proposal will be adopted? It depends the discussion among the stakeholders. So, generally speaking, that the design improve are always on the way. The design change should be finalized at the stage of the preliminary design. So, following this way, the reliable and economic nuclear power plant has been or will be delivered by CMPE.
It's fruiting that design, isn't it? It's avoiding the design changes seems to be key. Ken, the SMR project that you're looking at OPG, I understand you're also looking to support other regions and utilities that may be interested in also building that reactor system, because that will ultimately help your program.
Yeah, I think it's, as I mentioned a little bit earlier, I think we have Saskatchewan, so one of our 2 provinces over, have indicated they also want to go down the nuclear path, similar technology. I think we have other areas in Canada talking about the same technology, and then working a couple places elsewhere in the world, in Europe, towards the same end. And again, our view on this has been, if we can, almost to the top, the headline of the topic for today, to get enough volume so you can replicate. This is going to make everything successful. And I think we always have to look and go, ultimately, we're building these to decarbonize, and we want it to be a fair consumer price who's ultimately going to pay. for the cost of electricity, I think, in all of our jurisdictions. So I think that's why we've spent a fair amount of time trying to get like-minded entities into the conversation so that we can hit the serial production type of thing. I also think if you look around the room, sort of out beyond this session, there is an amazing supply chain across the world. And I think for a lot of the supply chain, they're looking for volume of activity, not a bunch of one-offs. So I think we sort of view it as yes, it's helping others, but also pretty self-serving, because we think our second, third, and fourth one become cheaper if we can get the serial production to the point where you just have more of the same thing being produced. So
I think it's like you said at the start in your opening introductory remarks, that there's enough here on collaboration for everybody, and that collaboration with other utilities potentially building ultimately helps you, because the supply chain gets more knowledgeable. Your projects will be delivered with greater certainty, delivered cheaper. It's all about this collaboration really across the supply chain.
Because I think, well, we view it, and it may be different by country, but we view the technologies might view themselves as competitors to each other. Once a technology is selected, we don't view other utilities as our competitors. At that point, it's, like say with us and Bruce Power, it is we collaborate on virtually everything to do with our plants, which makes them function better, that makes the refurbishments, life extensions better. And I think that's the way we've adopted across the people we're working with. Once it's the same technology, you're going to collaborate, not compete.
Fantastic, great approach. Mohammed, do you want to comment on that?
Yes, Paul. I just wanted to mention a point on the local supply chain and how that is important when it comes to security of supply of the program. Especially in our case, when it was a first-of-a-kind nuclear reactors in the country or the Arab world, we really put a lot of focus on how we secure that supply chain. And I'm happy to say right now, $7 billion has been put on the local supply chain. Right? For example, we really went off to being very active and went to qualify companies to be able to supply as a nuclear standard. And right now, the cable company called DUCAP, based on Dubai, they're supplying cables as we speak right now to Hinkley Point C in UK, supplying cables to nuclear plants in Korea. It's very strategic. It has a strategic importance, and we're always contributing to that local supply chain.
Great, that's a great example. Thanks very much, Mohammed. I'm conscious of time. I'm just going to ask my fellow panelists just for one quick key message that you wish to give to the audience about how best to take forward serial production and fleet build. So, Alan, if you'd like to start, what's your key message for this audience?
Of course, that with EPR model, EDF has a safe, robust, high-performance technology. Plus, because I don't have the opportunity to speak that much on supply chain, a end-to-end complete supply chain able to deliver it, and with which we are going to have a long-term win-win partnership relation. That's key. Second point is, after a period without construction, the new EPR reactor plus the, I would say, strong political signal enable us to relaunch completely the dynamic through Excel plan in order to regain the highest level of efficiency, quality, and rigor that we need for a perfect project execution. And today, as we can see at WNE, there are many industrials very mobilized on that fantastic project.
Fantastic. So it's about a win-win partnership for perfect project execution. Love it. Mohammed?
Thank you. If we look at the global signals throughout the world, I want to mention what Diane mentioned. There are a lot of countries right now embarking on their nuclear journey and their nuclear program for two obvious reasons. One being energy security, second being to meet their net zero targets. Now, as I mentioned, it's really good to be here right before COP. COP is happening in 2 days' time. It's going to be the official opening, and it will be really great to demonstrate the nuclear role within the decarbonization of the sector. To give you an example, those 4 reactors at Baraka, they're gonna contribute to more than 46% of our country's NDCs. That's the national deterministic contribution of reduction of CO2s. That's big. As John Kerry mentioned, there is no net zero without nuclear. And I want to highlight to what Sama Bilbao mentioned as we launched INEC and WNE, the net zero nuclear initiative during COP. And here we're going to declare, a lot of governments going to declare with us the tripling nuclear effort, and would like to invite you and see you all there to decarbonize our sector and reach to our net zero targets. Thank you.
Great, thank you, Mohammed, and we wish you well with a successful COP conference taking place starting next week, I believe. Thank you. Mr. Tai, what's your one key message then for this audience today?
I would like to talk about 2 points. The first is I would like to emphasize again for the safety and security is the precondition for the fleet construction. The second point is we discussed the supply chain right now. I want to say some more words regarding the how to manage the supply chain in CMPE. There is a qualified list with star level supply list. This list should be periodically assessment, and the supplier the supplier from overseas is included. That's for sure. And the supplier with a high star level will have the advantage in the tender process. And also CMP cooperated with the supplier to develop the supply capability. In the first IPR 1000, CMP cooperated with the supplier to develop 411 equipment. This equipment designed to anti the CV accident. And this equipment had passed qualification test, especially for the prototype equipment. And finally, I would like to welcome all your guests to visit CNNC platform. Maybe there is a surprise for you. Thank you all.
Brilliant, thank you, Mr. Tai. So I welcome you raising the safety and security point as well, and there's an invitation for anybody to go to see your stand here and the surprise as well. So thank you. Ken, what's your key message for this audience?
Sure, I think it's really simple. I think if we look at our Paris Accord targets, probably most countries here are on track to miss them. So I think we have to be honest with ourselves. There's no need to. And I do think that if on the industry side, you give policymakers confidence that this can be done right and will be a big part of the solution. And I think policymakers will respond well and then support and endorse all the things we want to talk about to get to serial production. And I think with in Canada, again, I think we're fortunate. We have great alignment among our provinces and federal government. And I'd say, if anything, the consistent question we get now is, can you go a little bit faster? Can you do a little bit more on the nuclear front, as long as with a lot of other technologies? So give policymakers the confidence to do what they should be doing so we can all hit the targets that we've set for ourselves.
Perfect, well said. Thank you, Ken. Diane?
So the targets are ambitious. They're not out of reach, but they do require decisions and choices to be made and investments to be made. It is exciting to see such a vibrant supply chain here at WNE. But to triple global installed nuclear capacity, the supply chain needs to significantly expand. So there is a vibrant supply chain, but if everybody who's saying they're going to build starts building or tries to build at the same time, I think we're going to have some bottlenecks. And so we're going to have to think about how to amplify the supply chain and increase the talent pipeline. We also have to anticipate that we probably cannot rely exclusively on the old guard. We are going to need youth, but we're also going to need to increase the talent pipeline by bringing women into the sector, by engaging indigenous people and communities, and by engaging the global south. We have to anticipate that it's not just about ramping up the supply chain that's here, it's about helping the new entrants into the supply chain learn how to be part of the nuclear sector. I think we're going to need new nuclear operators if we're going to triple global installed nuclear capacity. So we need to be thinking about new entrants not only in the context of new countries that are going to be embarking on nuclear to triple by 2050, but new actors, new supply chain, new people, new operators. And that requires collaboration. That requires some level of sort of collective vision and a shared sense of the direction that we want to go in as on a global level. So strategic collaborations amongst partner countries, so government to government, but also industry to industry, which you see a lot of business to business collaboration happening here, public-private partnerships, and obviously international partnerships. Those would be my remarks.
Fantastic. Thanks ever so much, Diane, and thank you also to our panelists. I think hopefully that's been a useful session for you to learn the experience that has taken place to date from fleet build, but also the opportunities that lie ahead. And I think as we see there, some great experience, but some fantastic opportunities for the supply chain companies that are here, and also new people that are hopefully going to come into this sector and have very rewarding careers. So thank you very much to our panelists, and I hope you found that useful. If we just show our appreciation to our panelists, and I'll close the session. Thank you.
Thank you so much, Paul.